Hello everyone, my name is Marcus Kender. I'll be explaining today how to solve dynamic problems that involve friction acting as a positive force on an object. For this question, you're asked to calculate how much force can be applied to the bottom box before the top box slips. The question tells you that the coefficient of kinetic friction between the bottom box and the ground is 0.4, and the coefficient of static friction between the two boxes is 0.25. The first step to solving this question is to draw a free body diagram for each box. I'm going to be analyzing each of the boxes individually. First, let's analyze the forces acting on the top box. There's Fn, the normal force, which acts perpendicular to the surface. There's Fg, the force of gravity, which acts straight downwards. Lastly, there is Fs, static friction, which acts in the same direction as the force applied. Friction in this case is positive because it's what actually drags the top box forward. The top box and the bottom box are locked into each other, and so when you push the bottom box forward, the top box will get dragged with it. This is represented in the following net force equation. Now that we're done with the top box, let's analyze the bottom box. There is Fn, the normal force, which acts perpendicular to the surface. There is Fg, force of gravity, which acts straight downwards. There is Fa, force applied, which is what you're solving for. There is Fs, static friction, which acts in the opposite direction as the Fs of the top box, and this happens due to the interaction between the two boxes. Lastly, there is Fk, kinetic friction, which opposes the motion of the bottom box and the ground. This is represented in the following net force equation. The question is asking you to calculate the force applied that will cause the top box to slip. For the top box to slip, you need to push the bottom box with a net force greater than the maximum friction between the two boxes. To find that value, you use the first net force equation that you created and you solve for acceleration, as I've shown you here. You're given all the variables that you need in the question. All you have to do is plug them into your equation and then isolate. You should get 2.45 meters per second squared for your acceleration. The system can accelerate more than that, or the top box will fall. The second step to solving this question is to use elimination to simplify the two net force equation that you created in the beginning. As you can see here, both Fs will cancel out, and you will be left with only Fa minus Fk ground. Fk ground is equal to the coefficient of kinetic friction multiplied by the normal force. Make sure that when calculating the normal force for this one, that you include the masses of both boxes. So you're going to do 15 plus 25. After you do that, rearrange the equation to isolate Fa because that's what you want to calculate for. For acceleration, you want to plug in 2.45 meter per second squared because like I said earlier, the system can't accelerate more than that or the box will fall. At the end, your final answer should be 255 newtons, which gets rounded to 260 newtons. That's it for this video. Thank you so much for watching. If you have any questions or want me to clarify anything, please leave me a message in the comments and I'll respond to you as soon as possible.